In this video, we're going to answer the question, why do you need a data warehouse? To develop the answer, it's helpful to look at a real application. Let's introduce you to Bob's Flight Tracker, everything for the airline buff. We have data about planes, we have data about routes, we have data about airports, and our users can ask any question that they want. The big question for us as developers, though, is what kind of database should we use for this application? Nowadays, there are two general types of databases that we can use, particularly in open source. We can use what's called a row store, which stores the data for each record in a single row. MySQL and Postgres are good examples of this type of database. The other kind of database that's available to us is called a column store, and in that the records are broken up and the columns are stored separately. This type of database is also called a data warehouse. Let's have a look at the effects of making a choice between a row store or a column store to answer specific questions. For example, one interesting question is to find late or delayed aircraft. So we have a relatively simple SQL query here, which is going to scan airline on-time data. That's a public data set published by the United States government. This particular example contains 170 million rows, one for each flight that is recorded. The query is interesting because even though it only requires 3 columns, it actually must scan the entire data set and look at values for those columns in every row in order to bring back an answer. Let's have a look at what this will look like depending on the database that we choose. If we load the data into a row store, what's going to happen is that in order to get the values from those 3 columns, we're going to have to scan the entire data set, including all the data in all the rows. So when the query runs, it in fact looks like this simulation, where we're basically walking down the data, reading all the data for the row, picking out the 3 columns that we're interested in, and then continuing to the next row. This is going to be really slow because in this particular data set, we have 59 gigs of uncompressed data. That's an enormous amount. We had to read all of it, pull it into memory, process it, and throw most of it away. In a column store, by contrast, the data are stored in columns. So we don't need to read everything in every row. We just read the 3 columns that we're specifically interested in. Let's show how this looks. So as the simulation shows, this is much faster because we're only reading a tiny fraction of the data. In fact, in this specific case, we're reading about 3% or 1.7 gigs. So that's already a huge improvement. But data warehouses do much better because one of their other features is that they compress the columns very efficiently. The reason that this is possible is that the columns are like arrays, and each of these arrays contains data of the same type, often with limited variation between successive values. As a result, these data compress extremely efficiently. So with row compression enabled, and it is by default, when we run the query, it completes very quickly. And as you can see down at the bottom, the reason it completes so quickly is it vastly reduces the amount of I/O we have to do. This compression has reduced the entire data that we have to read to about 21 megabytes, which is a reduction factor of something like 100-fold from the uncompressed data. There's one more thing that data warehouses do that make them very efficient at reading, and that is that they're able to break the queries up and read them in parallel. So we've talked about how the data is stored in columns. What data warehouses can do is they can take these columns, break them up into pieces, and then farm them out to different CPU cores. In this particular example, we have 8 CPU cores available for use. So we're going to break the query up 8 ways. Each CPU will now only have to read and process 2.6 megs of compressed data. Let's have a look at how fast that is. It's basically instantaneous. And this actually corresponds very well with what we see in the real world. So going back to this query to find late and delayed aircraft, we see the query and we run it, and what we find is that query completes almost instantly, in this particular case in about a quarter of a second. And that's in spite of the fact that it had to scan the equivalent of almost 174 million rows. So in summary, the reason that you should pick a data warehouse is because data warehouses give quick answers to open-ended questions on large data sets. If you're building applications like our flight tracker that have these three properties, a data warehouse is definitely something you should consider. And if you're looking for a data warehouse, why not pick ClickHouse? It's a great data warehouse. It's open source, it's extremely fast, it's portable, and it's easy to install. For more information about how to install and use ClickHouse, check out the great documentation at the clickhouse.tech website, or look at our videos and documentation from Altinity. Thank you very much. If you have more questions, don't hesitate to contact us at altinity.com. Thank you very much and have a great day.